All right, so 17.2 continued notes. This is, some years we get to this in honors chem and some years we do not. I'm going to go over it just quickly, and if it's very confusing, don't worry about it. You will definitely see it again if you move on to AP Chemistry, but if you're not planning to move on to AP Chem, this isn't a hugely important section of the chapter. Okay. And it's a lot of math. So my math-minded people, you guys will be happy. You can read this paragraph on your own. A rate law is an equation that relates the rate of the reaction to the concentration of the reactants. So before, we were looking at the rate of the reaction being a change in concentration over a change in time. And that's the slope of a graph that tells us how fast the reaction is happening. This is a little bit different because we're looking at how changing the concentration will affect the rate of the reaction. So like instead of starting A at 1 molar, if I started it up higher at 2 molar, what's that going to do to the rate of that reaction? Okay, and this is our generic equation for this part. A plus B forms C. So my reactants are A and B, and the product is C. And you guys can see in my rate law right here, C is left out completely because C is the product, and at the beginning of the reaction, there is no product. It's just reactants. So we're only going to look at the reactants and how changing them affects how fast the reaction goes. M and N are called the orders of the reactants. So we say the order of A, of reactant A, is N, and the order of reactant B is M. When you add those two exponents together, you get the overall order of the reaction. So if N was 1, so A was first order, and M was 2, B is second order, the overall would just be 3. So the overall order of the reaction is 3. So that part's pretty easy. Okay, here is an example. So for this equation, I looked up the rate law because you can't just look at an equation and write the rate law. So the rate law for that one is H2 to the first power or first order and NO2 to the second power or second order. Notice that this 2 here is not the exponent for H2. So they do not always match up. Sometimes they do. Okay, sometimes coincidentally these two things are the same. This coefficient 2 and this exponent 2 were the same, but they don't have to be. Okay, so how do we know what they're going to be? We have to have data, and that's where this little chart's going to come in. So we're going to use our math skills to figure out what N and M are. So we do that by running different experiments, changing the concentration and measuring the rate and seeing how it has changed for each concentration. So example, we have 3 experiments, 1, 2, 3. We have 3 different concentrations, and notice this one's pretty easy because there's only one reactant here. It's just HI, hydrogen iodide. So from here, experiment 1 to experiment 2, we double it. It went from 0.015 to 0.030. And this is brackets, so that means molarity, so moles per liter. And then what happened to the rate? These are really easy numbers. They aren't always this easy to see. From here to here, it went up by 4 times. So when I doubled the concentration, the rate goes up by 4. So we are going to compare the rate here to the rate here and know that we're looking for some exponent on this HI. Okay, let me see if I can write this out. So it always starts the same. We always have R equals lowercase k, and that's just a constant that we don't care about too much right now. The rate constant. Okay, and then brackets. The reactant is HI. Okay, and our job is to figure out what is this exponent going to be. I'm going to put a little question mark there. That's our job, figure out the question mark. So if I take this twice, and I'm going to compare this line to this line, when always put the bigger numbers. So I'm putting experiment 2. Actually, you know what? I'm going to switch it up. I'm going to use experiment 3. Put the bigger numbers on the top. So the rate here is 9.9. Okay, and the concentration right here is 0.045 to some exponent. Down here, I'm dividing it by this line, 1.1. Okay, and the concentration from line 1, experiment 1, is 0.015. Okay, and so we're comparing these two things. Let me underline this to kind of show that it's like a ratio. We're just comparing those two things. What is 9.9 divided by 1.1? 9, right? So that 9 comes from this ratio. And then I still have my equal sign. I'm just going to bring that down. K divided by K, that's 1, because those cancel out. And then I have this to some exponent, and this is the same exponent. So I can divide 0.045 by 0.015, which is the same as 45 divided by 15, which is 3. And the exponent will be the same. Okay, so I can take this, divide it by this, and keep the exponent outside the brackets. And now this is a really easy algebra problem. 3 to what exponent equals 9? And the answer is, do I have an answer over here? See a comment. 2. Very good. So the question mark, or you can call it X, or you can call it M or N. We're just trying to figure out the exponent. It's going to be 2. So that means when I wrote my rate law and I put a question mark, I'm going to go back up there and change it to 2. Okay, and so that is my rate law. Here is my answer. That's the rate law. You guys, after this, go ahead and try these 2 practice problems on page 574. And remember, the practice problem answers are in your book in the back, I believe. Okay, so you guys can look that up. So there is my rate law. Okay, so moving on, there are 2 red flag scenarios that actually make our lives really, really easy, and we don't need the chart. If it happens in a single step, like A bumps into B and bam, it forms C, there's no mechanism, there's no steps, it just happens instantaneously, then we can take the coefficient and make those the exponent. Okay, so you're looking for this red flag where it says single step, then it's just proportional to the product of the reactants. So you don't need the data. You don't have to do the little ratio that I did up here. It's just there's 1A, so the exponent's 1. There's 1B, so the exponent's 1. The overall order of this reaction would be 2. You add those 2 together. Okay, oh, if I reverse it, that's sneaky. If I reverse that reaction, it's single step. This would be, now C is my reactant. So C is the only one in the rate law. And 2 becomes the exponent because there's a 2 in front. So that's only for single step. And then there's one more red flag that you're looking for. If they tell you, like usually they write it like this, which one is slow and which one is fast in a mechanism. Remember, a mechanism is just this, all the steps that lead to a reaction, a net reaction. If they put slow, that's telling you that step 1 right here is the rate determining step. It's the slow step. So this is what's holding up the entire reaction from taking place. So my rate law is just going to involve my slow step. Okay, and I don't love this example because it's kind of confusing. They wrote NO2 plus NO2, which is just 2 NO2, right, guys? So I'm going to put NO2 in brackets. And because there are 2 of them, really, the coefficient should be 2. So that means that the order, second order, the order is 2. So So that's the rate law. Okay, and last time in 17.1, we looked at putting these together, these two steps, and writing the net. So we just look at what cancels out. The NO3 cancels. What else cancels? One of these, oh, that's why they wrote them separate. One of these NO2s cancels here. And my net would be, I have one of these left. Let me just copy it and paste it down here. So that's one reactant. That has canceled and that has canceled. CO, oops, plus CO is my other reactant. And my products are NO3 cancels, NO did not cancel. So NO is a product. Oops. Product, and then the NO2 is canceled, CO2 is the other product for this reaction. So that would be my net equation. And this would be the rate law for this equation. So CO, even though it's in the net, the rate doesn't depend on the concentration of carbon monoxide at all because it's not in the slow step, it's in the second step that happens really fast. So if the amount of CO, if I tripled how much CO was in there, it doesn't affect the slow step, so it's not going to affect the rate of the reaction. Only the slow step affects the rate. Okay, for this one, I think I'm going to let you guys write the net, and then the rate determining step is step 1. It tells us right here that it's slow, so you guys can write out the rate law for that one. Okay, so I'll let you guys do that on your own. One-step mechanism. This is our red flag. It's one step. What is the rate law for that? It would be R equals K, concentration of X, times the concentration of Y. And because it's a single step, one step, this becomes our exponent. So the exponent is 2. Okay, done. Easy peasy. Okay. Oh, these are really good. Determine the effect of doubling the concentration of X. If this is my rate law right here, what happens if I double X? If this becomes 2X, what happens to the rate? The rate should also go up by 2. If I double this, then this doubles to keep the equation correct. What happens if I double Y? I'm going to let you guys think about that for a second. See if you want to answer in the chat. If I double Y, what happens to the rate? Multiply the rate by 2. If I double Y, the rate does not go up by Y. Anybody know? I'll give you a few more seconds. Very good. Yes, that was almost a tie. Sienna and Ariana got it. So if I double this, let's just put a 2 there. What happens? This whole thing is squared. So the 2 becomes squared and the Y becomes squared. And so I'll get 4Y squared. And that means that it was 4 times bigger. So the 4 times the rate has to happen to make that equal. Okay. If I use 1/3 the amount of Y, so if this is 1/3 instead, 1/3 squared would make it 1/9. Is that correct, guys? 1/9. So the rate would go down or would be multiplied by 1/9. Okay, here's some bonus problems. If you want to challenge, you can do them on 55 left. Those are in your textbooks, number 10 through 16 on page 582. I believe that's in the back of the chapter. Okay, and that is basically it for chapter 17. Do you guys have any questions? Good, it looks like you guys got it. Okay, and remember, if you didn't, sometimes we don't even get to that in a normal year. So if you understood it, you can be really proud of yourself. You did excellent. Okay, I'm going to stop recording and give you guys